One of my favorite types of questions is to provide the student with, say, two choices, both of which have the same outcome on paper, and ask them which is the best choice to produce the indicated product. And I think this requires a high level of thinking, good knowledge of all the different types of reactions and their possible outcomes, such as regioselectivity and stereoselectivity. And it just really requires us to put everything together and make an informed decision here. So let's look at a couple of these for practice, because you'll see them on quizzes in the later half of the semester, and certainly on exam 3 and on the final exam. So here's a question. Here's a question that might say, which reaction, A or B, is the best choice to produce the indicated product, which in this case is simply a primary alcohol. It's not very exciting, and we have two options. We have H2SO4 and water, or we have boron BH3THF and peroxide and NaOH. So we have hydroboration oxidation versus simply the acid-catalyzed hydration. And it's important to remember then that the hydroboration oxidation gives us anti-Markovnikov addition. And the major product up here is Markovnikov addition of water, and so that would be OH adding to that carbon there. Let's try to use a different color, just make it a bit more interesting here. So on the top reaction, we would expect the OH to add to this secondary carbon, which is this one here on the alkene. And so the correct answer would be to circle the bottom choice, and oftentimes, or all the time, it asks you for a one-sentence explanation. And if you don't give me that explanation, you're only going to get a few points for basically guessing correctly. And so here, you could even just write hydroboration proceeds via anti-Markovnikov addition, giving the primary alcohol, and H2SO4 and water proceeds via Markovnikov addition, which would not give the desired product. So it's often, we don't need a novel here. We just need one sentence explaining. Sometimes it's as simple as, well, the regiochemistry is wrong in A, and it's correct in B. All right, so let's look at these two other choices down here. We have, again, an alkene on the end. We have a stereocenter here. And the outcome in this case is a set of diastereomers, because this stereocenter is unaffected by the reaction. At least that's what we're indicating with this product distribution. And we form both chiral centers that we could form at this carbon here. And so the first option is the hydroxymercuration. In this case, methanol is our nucleophile instead of water, and that ends up with MEO on our reaction. So this is perfectly valid way of putting on a methoxy. In this case, we have acid, and again, our nucleophile is methanol, and that is also a reasonable way to put a methoxy group on. However, the difference here is that cations will form under these acidic conditions. So we would get a cation that would look like this. And certainly methanol could add to that cation, but also we might expect a rearrangement of that cation, giving us a tertiary cation. And then methanol could add to that, but it's not going to produce the desired product. And if you read the book clearly, when we talked about the mercuration reaction, this does not produce cations. And that there is the key. So that means there will be no rearrangement is possible if there are no cations. And thus the top reaction is the best choice because it doesn't form cations. And the cations will oftentimes allow for rearrangements. They'll allow for perhaps other nucleophiles to be used if we have that opportunity in there. And so if you are faced with the choice that one of them, in this case D, forms a cation, and one of them, C, does not, and both could lead to the desired products, you're going to choose the non-cation forming reaction every time, because cations can lead to rearrangements or additional products with maybe different nucleophiles, or potential racemization if that's not our goal. So anytime we can do the reaction and get the desired product, as we do right here, without forming cations, we're going to choose that. So in this case, we would choose C, and the reason is that the mercuration reaction does not form cations. Okay, a couple more. Here is what looks like an elimination type mechanism. This is a strong base / strong nucleophile. And we would expect that to proceed via E2 mechanism. Here we have a weak base / nucleophile. And these are secondary substrates. If you remember from the end of Chapter 8, secondary substrates with a weak base and weak nucleophile are impractical. And one of the reasons is that it's a really slow reaction because the secondary substrate is slower to give up its leaving group and form a secondary cation that's higher in energy. And also, you could get a large mixture. So we have a slow reaction and we'll call that a large mixture of products. SN1 could compete. So a lot of different things could happen in this top reaction. We'll call this A and we'll call this B. Whereas in the B, we have basically only E2 would occur, and we have a small base here. And so that's going to give us the Zaitsev product. And that's what we formed here, the more substituted. We could also eliminate from that hydrogen, but our small base is going to preferentially choose that hydrogen. And we see that they are 180 degrees from each other. And so we know that we're going to form the E version, and that's the desired product. And so those are all good reasons here. I think the best answer is to circle B, and then, actually we'd circle the whole thing, but I'm trying not to be messy here. We'd circle the entire scheme of B, and then we'd write that basically A is impractical because it's slow, it has a weak base, weak nucleophile. It would give us a large mixture of products, and we'd get some competing SN1 type chemistry. We might get a rearrangement because we know that E1 and SN1 go through the cation intermediate, and that would give us another number of products that could form. So oftentimes the answer here is going to be to circle the one you like, and then give me a sentence telling me why the other one is not good. Most of the time that's how we earn full credit. Why is the other choice not as good as the one that you circled? I know that you think the one you circled is best, and so you could also give me a sentence that supports that, but most often it's going to be explaining why, in this case, A is not a good choice. One more here, we have C and D. These are primary substrates. We have, again, strong base, strong nucleophile. This one is in the weak base, weak nucleophile category, and our goal here is to do a substitution, not an elimination. And I think it's basically going to be the same argument as up top. The weak nucleophile, weak base is impractical. It's going to be very slow because this is a poor nucleophile. It's not negatively charged, and so it's going to be less likely to do this arrow push. So it's going to be really slow. When it does that arrow push, we'll get this product, but most likely we'll be waiting a while. So this one's very slow. The better nucleophile is fast, and primary supports SN2 type chemistry, and so we would circle the top and basically write very slow mixture of products, whereas we're likely to get either a smaller mixture of products or only the SN2 substitution for C. So we would circle C and basically argue against D by saying that it's slow and gives us a mixture of products. You can look at a few more examples on the key of exam 3 from fall of 14, and there's probably one or two other examples on some of the later quizzes in fall of 14 as well. And we'll put some more examples on upcoming practice worksheets, and we'll give a bit of opportunity to look at this in class as well.